The discovery of Comet 3I/Atlas has opened an extraordinary new chapter in humanity's exploration of the cosmos, combining rigorous scientific investigation with intense public fascination and speculation. Detected on July 1, 2025, by the ATLAS Asteroid Terrestrial Impact Last Alert System survey, 3I/Atlas immediately stood out as only the third confirmed interstellar object ever observed entering our solar system from the depths of interstellar space. Unlike comets and asteroids that originate within the sun's gravitational domain, this object is traveling on a hyperbolic one-way trajectory, meaning it is not bound to the sun and will never return once it departs. Racing through the solar system at an estimated speed of about 58 kilometers per second, 3I/Atlas is a true cosmic wanderer, a messenger from another star system that formed billions of years ago under conditions likely very different from those that shaped our own planetary neighborhood. Orbital calculations performed soon after its discovery showed that the comet would reach its closest point to the sun, known as perihelion, around October 29, 2025, at a distance of roughly 1. For astronomical units, this places it inside the orbit of Mars, but still well outside Earth's orbital path. Crucially, both NASA and the European Space Agency have emphasized that the object poses absolutely no threat to our planet, as it will never come closer than about 1.8 astronomical units, or approximately 270 million kilometers. This reassurance has been repeated consistently by planetary defense experts, underscoring that while the comet is rare and scientifically valuable, it is also completely benign in terms of impact risk. For astronomers, the excitement lies not in danger, but in opportunity, a fleeting chance to study material that formed around another star. What truly sets 3I/Atlas apart, however, is not just its interstellar origin, but its apparent size, speed, and level of activity. Astronomers analyzing data from powerful observatories, including the Hubble Space Telescope, have suggested that the solid nucleus of the comet could be several kilometers across, already making it larger than the first known interstellar visitor, 1I/Oumuamua. Even more striking are alternative interpretations of observational data indicating that the object might be surrounded by a massive cloud of dust, potentially giving it an effective diameter of 20 to 46 kilometers. If this interpretation proves correct, 3I/Atlas would be the largest interstellar comet ever observed and possibly one of the oldest, preserving material from an ancient stellar environment. Despite being far from the sun at the time of discovery, the comet was already extremely active, displaying a visible coma and tail, behavior that suggests volatile-rich material responding vigorously to solar heating. As the comet continued its journey inward, astronomers began to notice increasingly puzzling features. In late August, telescopes detected a rare and visually striking phenomenon known as an anti-tail, a plume of gas and dust that appeared to point toward the sun rather than away from it. While such features are uncommon, they are not entirely unknown in comet science and can be explained by complex interactions between dust grain sizes, viewing geometry, and solar radiation pressure. Nonetheless, the presence of an anti-tail added to the sense that 3I/Atlas was an unusually complex object, encouraging both serious scientific debate and more speculative interpretations. No figure has done more to amplify the speculative side of the discussion than Dr. Avi Loeb, a prominent Harvard astrophysicist known for his willingness to entertain unconventional ideas. Loeb has publicly suggested that there is a significant probability, at times quantified by him as high as 40%, that 3I/Atlas could represent some form of extraterrestrial technology rather than a purely natural comet. He has argued that the object's size, speed, composition, and trajectory raise questions that cannot be dismissed outright. According to Loeb, the comet's upcoming close passage around the sun represents a critical acid test. If after merging from the sun's glare, 3I/Atlas were to deviate significantly from its predicted trajectory in a way that cannot be explained by natural outgassing or gravitational forces, it could imply deliberate control. Such a discovery, Loeb has warned, would have profound consequences not only for science, but for society at large, potentially triggering global economic turmoil and even a stock market crash as humanity confronts definitive evidence of alien technology. Fueling this debate are several reported anomalies in the comet's physical and chemical properties. Spectroscopic observations have suggested that the comet is venting nickel gas without a corresponding detection of iron, a combination that is rare in natural solar system objects and on Earth, typically associated with industrial alloys. Additionally, the composition of a coma appears to be highly unusual, with estimates suggesting it is dominated by carbon dioxide, up to 95%, with only a small fraction of water vapor. This is almost the inverse of what astronomers observe in typical comets formed in our solar system, which are usually rich in water ice. Furthermore, 3I/Atlas is traveling along a path closely aligned with a plane of the solar system, a configuration Loeb has described as finely tuned. The comet's relatively close pass by Mars, at a distance of about 30 million kilometers in early October, has been cited by him as another example of what he considers remarkable alignment, consistent, in his view, with the behavior of a probe designed to survey planetary systems. The speculation did not stop there. In interviews and podcast appearances, including a widely discussed episode of the Joe Rogan Experience, Loeb floated the idea that even if 3I/Atlas does not change course, it could still deploy smaller probes during its passage through the inner solar system. These hypothetical mini-probes, he suggested, might quietly visit Earth or Mars without being easily detected. Such statements, while clearly labeled as speculative, ignited a wave of sensational media coverage and online discussion. The comet was quickly dubbed the Halloween Comet, with headlines suggesting that revelations about its nature could keep the public awake with anticipation or anxiety through the end of October. Social media platforms became flooded with memes, conspiracy theories, and doomsday rumors, demonstrating how quickly scientific uncertainty can be transformed into viral spectacle. Despite the noise, the overwhelming consensus among astronomers and space agencies remains firmly grounded in conventional science. Experts at NASA, ESA, and observatories around the world emphasize that everything observed so far can be explained within the framework of cometary physics. As ESA scientist Dr. Michael Kuppers succinctly put it, it looks like a comet and it behaves like a comet. No credible evidence of artificial structures, propulsion systems, or intentional maneuvers has been detected. The sunward-pointing anti-tail, for example, can be reproduced in models where carbon dioxide outgassing from the sunlit side of the nucleus lofts dust grains into trajectories that appear to point toward the sun from Earth's perspective. Similarly, the unusual chemical composition may simply reflect formation in a star system with a different elemental makeup, perhaps older and more carbon-rich than our own. Rather than being a threat or an alien artifact, 3I/Atlas is widely viewed as an unprecedented scientific gift. The global astronomical community has mounted an extraordinary observation campaign to take advantage of this rare visitor. In early October, as the comet passed near Mars, 2 ESA spacecraft orbiting the Red Planet, Mars Express, and the ExoMars Trace Gas Orbiter, successfully imaged it, marking the first time in history that probes around another planet have observed an interstellar object. Although the comet appeared only as a faint fuzzied, tens of thousands of times dimmer than typical targets, the achievement was historic. On Earth, some of the most powerful telescopes ever built, including Hubble, the James Webb Space Telescope, Keck, Gemini, and the Very Large Telescope, have been monitoring the comet's brightness, composition, and dust production. Early analyses suggest that it is shedding dust at rates of tens of kilograms per second, and that its nucleus may be billions of years old, offering a glimpse into conditions that prevailed during the early history of another planetary system. The observation effort extends beyond traditional astronomy. Spacecraft already en route to other destinations have been enlisted to collect additional data. After perihelion, ESA's JWST mission, bound for Jupiter's icy moons, is scheduled to turn its instruments toward 3I/Atlas. Even more remarkably, trajectory calculations indicate that ESA's Hera mission and NASA's Europa Clipper may pass through the comet's extended tail, potentially sampling ions and dust from an interstellar object as a serendipitous bonus to their primary missions. Such opportunities are extraordinarily rare and highlight the adaptability and ingenuity of modern space science. As October 29th approaches, anticipation continues to build. During perihelion, the comet will pass behind the Sun from Earth perspective, disappearing into the solar glare and creating a temporary